Hello students, hope that all of you are doing well and staying at home and continuing your studies. Today I am continuing with class 10 mathematics chapter 1 real numbers exercise 1.1. In my previous class I have done first 3 questions of this exercise, so I am continuing with question number 4 in this video. Question number 4 is: use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. I repeat the question. Show that the square of any positive integer, is of the form 3m or 3m plus 1 for any integer m using Euclid's division lemma. So, let us assume the positive integer as a. Let the positive integer is equal to a. Now we are asked to represent the square of this positive integer in the form of 3m or 3m plus 1. So after looking at that 3m or 3m plus 1, I am taking the second integer, that is our b, as 3. So let the second integer or b is equal to 3. In the previous class we have studied for any two integers there exists two more unique integers q and r such that a is equal to bq plus r. So using the same Euclid's division lemma, now we can write a is equal to bq plus r, that is 3q plus r. And what is the condition for r? Where r is greater than or equal to 0 but less than b, divisor. And what is the divisor here? 3. So using Euclid's division lemma we can write a is equal to 3q plus r, where r is the remainder. And the remainder here is more than or equal to 0 but less than 3. So what are the possible remainders? 0, 1 and 2. So I am writing this in the exact order, that is I am giving the values of the possible remainders. The first possible remainder is 0. So 3q plus 0 or 3q. I am taking it as equation number 1. Or the second possibility is 3q plus 1. When the remainder is 1, it will become 3q plus 1. Now what is the other possibility? Or the third possibility is 3q plus 2. So when a number is divided by 3, the possible remainders are 0, 1 and 2. So we will get these 3 possibilities for a. A can be 3q, or a can be 3q plus 1, or a can be 3q plus 2. Now here the question is, we have to express the square of a. In the previous question it was only a. Now in this question we are asked to prove the square of a is in the form of 3m or 3m plus 1. So now we have to find the square of each of this equation. So now I am taking the first equation. Now equation 1 square. Squaring equation 1 we get a square is equal to 3q the whole square. 3q the whole square is 9q square. Now we are asked to prove a square as 3m or 3m plus 1. What does it mean? We have to express the answer of a square as multiple of 3 or multiple of 3 plus 1. Means we have to try to take out 3 as common from the RHS. Either 3 common in all the terms, or by taking 3 common, we must get only 1 outside the bracket. Here we can see in 9q square 3 is common. So I am taking 3 common. After taking 3 common, what will be left inside? 3q square inside. This 3 into 3q square can be written as what? 3m. Now what is m? After 3, whatever is left out in the bracket, that will become m. So this can be written as 3m, and you continue where m is equal to the bracket that we got, that is 3q square. I hope you understood it. So squaring equation number 1, we got 9q square. Now we have to make it in the form of either 3m or 3m plus 1. 9q square can be made easily in the form of 3m. How? Taking 3 common, we get 3q square inside the bracket. What is inside the bracket is immaterial. What is important is we have to show our RHS is in the form of 3 into something. That something will be treated as m. So we got 3 into something inside the bracket. That bracket is m. So we got the answer 3m. Now similarly we have to continue with equation number 2 and equation number 3. Now I am going to square equation number 2. Now equation 2 square gives a square is equal to 3q plus 1 the whole square is equal to, now it will be opened by using the formula a plus b the whole square. 3q the whole square, 9q square plus 2ab. 2 into 3q into 1, 6q plus b the whole square, 1 the whole square is 1. Now we have to express it in the form of either 3m or 3m plus 1. Now all of you can see very well that there is 3 common in first and second. So take 3 common from first and second. Taking 3 common, it will become 3q square plus 2q. But there is no 3 common in the third term, so this plus 1 will remain as it is. Now it is in the form of 3m plus 1. I told you anything can be inside the bracket, that bracket will be treated as m. So we got 3 into m plus 1, where below that you write where m is equal to this bracket. What is that? 3q square plus 2q. So here we got 3m plus 1. Here we got 3m. So 2 steps are over, 2 possibilities are over. In the first one we got 3m. In the second one we got 3m plus 1. Now the third equation is left out, that is 3q plus 2. Now I am taking equation number 3 and squaring it. So it becomes a square is equal to 3q plus 2 the whole square. Open the bracket using a plus b the whole square formula. A square, that is 9q square, 2ab, 2 into 3q into 2, 12q, plus b square, that is 2 square, that is 4. Now we have to express it in the form of either 3m or 3m plus 1. There is 3 common again in first and second term. But when we take 3 common, something will be left in the bracket. But outside the bracket we are going to get 4. But we need to get 1. So how can we make it 1? This 4 can be written as 3 plus 1. So I am going to write it again. 9q square plus 12q plus 3 plus 1. This 4 is splitted as 3 plus 1. Now you can see the first term, second term and third term. What is common? 3 is common in the first 3 terms. What will be left out? 3q square plus 4q plus 1. And outside the bracket we will have plus 1. Now this can be written as 3m plus 1, where m is equal to 3q square plus 4q plus 1. So we got the final one also, third also as 3m plus 1. So the first one was 3m, second and third are in the form of 3m plus 1. I hope all of you understood. If not, see the video again. So we have taken b as 3. So using Euclid division lemma we got a is equal to 3q plus 0 or 3q. Second one 3q plus 1. Third one is 3q plus 2. Then we have taken the square of all the 3 equations. Then all that after squaring we got the first one as 3m, second and third one as 3m plus 1. Please practice it by yourself. Now the next question, that is question number 5. Question number 5 is, use Euclid's division lemma to show that the cube of any positive integer, is of the form 9m plus 1 or 9m plus 8. Just like the previous question. In the previous question we were asked to represent the square of the given positive integer as 3m or 3m plus 1. Now cube. So let the positive integer to show that the cube of any positive integer. So let the positive integer is equal to a. Now we are asked to represent the cube of this a in the form of 9m plus 1 or 9m plus 8. This question can be done in 2 ways. By seeing the answer, by seeing that 9 in the answer, you can take the second integer b as 9. But when we take 9, what are the possible remainders? 0, 1, 2, 3, 4, 5, 6, 7, 8. You will get 9 equations. And as we did in the previous question, you have to cube all the 9 equations. The answer will be too lengthy. So this question can also be done by taking b is equal to 3, just like the previous question. So let b is equal to 3. Now using Euclid's division lemma, now we can write a is equal to 3q plus r, where r is less than or equal to 0 but greater than 3. So I am writing it directly, either a is equal to 3q plus 0 or a is equal to 3q, equation number 1, or a is equal to 3q plus 1, equation number 2, or a is equal to 3q plus 2, equation number 3, just like the previous question. So I have not written that general line 3q plus a is equal to 3q plus r, where r is greater than or equal to 0 but less than 3. Now you understood what does it mean? It means this time we can have 3 remainders, 0, 1 and 2. So these are the 3 possibilities. Now what are we supposed to do? Taking cube on both sides. So equation number 1 cube gives a cube is equal to 3q the whole cube. We know that 3 the whole cube is 27q cube. But we are supposed to express it in the form of 9m. So we know that 9 is common in 27. So it is 9 into 3q cube is equal to 9m, where m is equal to 3q cube. So we got the first one. The cube of a is 9m. Now in the same way second and third are left out. In the same way we will do equation number 2 the whole square. Sorry, whole cube. So next one is equation 2 the whole cube gives a cube is equal to 3q plus 1 the whole cube. Now I hope all of you remember the identity that you have studied in class 9. A plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Remember, a plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Remember this formula. Remember this identity. Now using this identity, I am going to expand 3q plus 1 the whole cube. First one is 3q the whole cube. This is 27q cube plus 3 into a square into b, 3 into 3q the whole square, 3 into 9q square, that is 27q square into b, b is 1, plus 3ab square, 3 into a 9q, 1 square 1, so it is 9q, plus b cube, b cube means 1 the whole cube, that is 1. Now see, we are asked to represent the final answer either in the form of 9m or 9m plus 1 or 9m plus 8. Now you can see first, second, third. 9 is common in the first 3 terms. So you know the answer. We are going to take 9 common from the first 3. So this is 9 into 3q cube plus 3q square plus q bracket close plus 1, which can be written as 9m plus 1, where m is equal to the above bracket, that is 3q cube plus 3q square plus q. So we got the second answer, a cube is equal to 9m plus 1. First answer, a cube is equal to 9m. Now we are going with the third one. And now I am doing equation number 3 the whole cube. That is a cube is equal to 3q plus 2 the whole cube. Once again, a plus b the whole cube. A cube, that is 9q cube plus 3a square b. Okay. Since the numbers are more, I am taking one more step. First term is a cube plus 3 into a square into b plus 3ab square, 3 into 3q into 2 square plus b cube, that is 2q. So this is a cube, this is 3a square b, this is 3ab square, and this is the last term. Okay, a cube, 3a square b, 3ab square plus b cube. Now expand. 27q cube plus 3q the whole square is 9q square. 9 into 3, 27, 27 into 2, 54q square. Plus 2 square is 4, 4 into 3, 12, 12 into 3, 36 cube. Plus 2 cube is 8. Now we have to express it in the form of 9m plus 1 or 9m plus 8. Now you see 27, 54, 36. 9 is common. So what will be left out outside the bracket? Plus 8. So it is 9 into 3q cube plus 6q square plus 4q plus 8, which can be written as 9m. This bracket is m plus 8. 9m plus 8, where m is equal to 3q cube plus 6q square plus 4q. So that is the end of the solution. In the first one we got 9m, second one we got 9m plus 1, and in the third one we got 9m plus 8. So we have seen two questions today. Both the questions were almost of the same type. Both the questions are important. Previous question was to express square of the given number in the form of 3m or 3m plus 1. Here, cube of the given positive integer as 9m, 9m plus 1 or 9m plus 8. That's all for today. Since both the questions were a little lengthy, I am winding up this class. So please practice both the questions until you understand it thoroughly. So take care of yourself and continue your studies. Bye bye.